Good morning. So today we're looking at the Metro Central Education District, the Common Paper 2021, question 5. Okay. So in 5.1 we are told that g of x equals a half raised to the x. So this is your exponential function. The question says write down the equation of g to the minus 1. So they're asking you to write down the inverse function. Okay, so for the inverse function, so you go 5.1.1. So for the inverse function, what we do is we interchange x and y. Okay, so in other words, that will become x is equal to a half raised to the exponent y. But they want it in the form y is equal to something. Alright, so we know that log of first the exponential form, a raised to the x equals y. So that is going to be x is equal to log y base a. Remember, the base remains the base. Okay, those are the lines in your book. A would be like a subscript. Okay, so if I take that into account, that would simply be y equals log x base of. Okay, and that's the inverse function. Of course, there's another way it could have been written. If I had said you got x is equal to a half to the y, a half can be written as 2 to the negative 1, which then can be written as 2 to the negative 1. Okay, so in log form it's going to be negative y is equal to log x base 2. Of course, you want that to be positive, so it's negative log x base 2. Okay, so these are equivalent solutions. Okay, you can either have it in that form or in the latter as I have it there. Okay, in question 5.1.2, the second question, it says sketch the graph of the inverse function showing at least 2 points which must include any intercepts with the axis. Any asymptotes must also be clearly shown. Okay, so if you're looking at this graph here, we use normally a table to draw this graph. So we've got x and a y. For the log graph, remember we're drawing this graph. For the log graph, we write negative 1, 0 and 1 in the denominator, in the y column. Okay, so in the y row. So to get the corresponding y value, we say negative 1 is equal to, if I see y, I put the negative 1 equals log x base a half. So if I put that onto the half, x is then equal to 2. Okay, so this would now be a half to the negative 1. Okay, where it converted back to exponential form. Okay, or I could use this here. It would be much easier, because then x would be equal to a half raised to the y, and y is 0 here. So half to the 0 is 1. If I put 1 in here, then I get x is equal to a half to the 1, which is half. Okay. Why don't I put it where I see x? Because these conditions or the restrictions on the log graphs, there's a lot of theory. You must remember that the x can't be negative and all of those things. So this will make it easier for you to remember. So if we draw this graph, okay, you got the y and your x here. So x is 2, so we go 1, 2, x is 2, y is negative 1. Okay, we must indicate at least 1 point on the graph as indicated. That is your intercept, and this is of course your asymptote. So if x is a half, y is 1. The graph is coming through like that, and there we go. It's a smooth curve coming through to a negative 1 as well. Okay. Remember, your y-intercept is your asymptote, and it's clearly marked there. You can't intersect this line, cross that line at any stage. Okay. The 5.1.3. Let's just take this off. It's going to write here is equal to log x base half. So that I can take this off. Is it also off here? I might need this graph here, so let's keep that. Okay. In 5.1.3, the question says if the point G, which is 4 and K, lies on the inverse function, determine the value of K. So if you're going to look at 4 and K, so your X value is 4, so I need to extend this. So 4 would be approximately there. If I extend that, 4 would lie here somewhere. So that is 4 and some K value. Okay? How do we get to calculate the value of K? Since the 4 and K lies on the inverse function, I will substitute that into the inverse function. So we will substitute 4 and K into G of X, the inverse function. Okay? Remember, this is a y and that is your x here. Okay? So your k is a y. So k is equal to log x, which is 4, base half. Now we can use the log laws. Okay? But many a times we are not exposed to the log laws, so we can punch in the calculator. I'll show you now how we do that. Otherwise, if you know the log law, that is going to become log 2 squared over log to a half, which is 2 to the minus 1. Bring the exponents forward, so it's 2 log 2 over negative 1 log 2, which gives us negative 2. Now say you didn't know that, okay, and you're not familiar with the log law, then we just punch this into the calculator. Log 4 base half. Just get the calculator on the screen quickly. Calculator. Just pause. Okay, so as I said, we can put this in the calculator. It would simply be log. So you please first declare the calculator. Shift log. Oops. Not shift, just log. 4 base half. It gives us negative 2. So either way, you would get that answer out there. I'll just remove it again. Okay. Then in question 4, they want to know for which values of x is the inverse function greater or equal to 2. Okay, so I need to take this off here. Needs to be greater or equal to 2. The inverse function. So that's the one that is drawn there on the board. So we need to first see where's y equal to 2. Okay? Remember that's y is equal to negative 1. So we don't have 2 on the graph, but 2 would lie here somewhere. This is y is equal to 2. The 2 would lie there somewhere. Okay? So the inverse function, so let's check the value for at which x this actually happens. I think it's at, you don't guess, it's a quarter, but okay. The inverse function is log x base a half equals 2. So we convert to exponential form. So x is equal to a half, and remember the base remains the base, which is then a quarter. So at x is equal to a quarter, so that's a quarter and 2. The question is where's g of x greater than or equal to 2? So it's this part of the graph they're looking at. So it's from 0 till a quarter. Okay? So x is continuous, so x has to be greater than 0, but less than a quarter. Okay? But there's an equal sign as well. Okay? So can it be equal at the 0? No, asymptote. Can it be equal at the quarter? Yes. So there's a solution there. Either like that, or it can be written as x is greater than 0, and it can't be or. It must be the intersection thereof. Okay? So x must be greater than 0, or, and x must be less than or equal to a quarter. It's either that or that solution. Okay? Then in question 1.5, just change the color here. In question 5.1.5, they said calculate, give the equation of h of x, the reflection of g of x in the y-axis. So if something is reflected in the y-axis, the rule is x becomes negative. Reflection in the y-axis, x becomes negative. So x becomes negative. So what is the equation of g of x? G of x is defined as a half to the x. So if the x becomes negative, therefore y equals a half raised to the minus x. That you'll get you one more there already. And this is your h of x graph. You could simplify this, and this would have been y is equal to 2 to the x, but there's no marks on that if you had simplified it or not. Okay. So that sums this question up here. Okay, so for question 5.2 we are told the graph of f of x equals a times b to the x plus q. So that is your exponential function, is sketched below. Points k, which is 2 and minus 2, that's your y-intercept, and r, which is 1 and negative 4 on the curve of f. Determine the value of the values of a, b, and q. So from the offset we know that your q value is your horizontal asymptote. Okay, that is, so your q is sorted. Horizontal asymptote is labeled as negative 1. So my equation now reads f of x equals a times b to the x minus 1. Okay, so that is sorted. Then, to calculate, your a and your b are going to start off with k. You could have started with r, no problem. It's just a bit easier to start off with k. So you will substitute k, which is 0 and minus 2. Remember, that's an x and a y. Okay? So that f of x is a y, so negative 2 is equal to a times b to the 0 minus 1. Anything to the power 0, of course, is 1. We take that over. It becomes minus 2 plus 1 is equal to a. So a is negative 1. Okay? So there's your q, there's your a. Then they want you to calculate b. So my equation now reads f of x equals a, which is negative 1, times b, or I could have left the 1 out, to the x minus 1. Now to calculate your b value, I'm going to substitute the other point that's lying in the graph, which is r. So let's substitute r, which is 1 and negative 4. Again, this is an x and a y then. Okay? So we have negative 4 equals negative 1, b to the 1 minus 1. So I take that over. We have negative 4 plus 1, which is negative 3, minus b. B is there, 3. Okay? So there we got our values for A, B, and C. Okay? So that brings us to the end of question 5.5. Okay?